Compound objects are objects made with two different objects. To illustrate this point, we're going to start by using a box and a sphere to create a compound object. In a later example, we use a sphere and a cone. Place a box in the center of your scene, and then place a sphere right next to it so that the sphere cuts into the box, and we'll explain why in just a moment. Go to the pull-down menu and select Compound Objects. You'll notice that there are 6 different compound object types. There's Morph, Conform, Shape Merge, Scatter, Connect, and Boolean. Because this is a basic disk, and we don't have the time to really get into all of these, I'm going to choose the 2 most important types, the Scatter and the Boolean. Let's start with the Boolean. With the sphere selected, click on Boolean. You'll notice that the stack changes to reflect that selection. If we use the hand tool to scroll down a little bit, you'll see that under parameters we have 2 operands, an A operand and a B operand. In a Boolean operation, in a Boolean compound object that is, we have an A and a B operand. Because the sphere was selected when we clicked on Boolean, it became the A operand. We need to select a B operand to complete this Boolean object. So, click on the Pick Operand B button, and then select the cube. You'll notice that something happened. The object changed here in your view, and you'll also notice that under parameters, the box became the B operand. Use the hand tool and scroll down a little bit to the operations section. There are 3 different types of Boolean operations. They are union, intersect, and subtraction, and there's 2 flavors of subtraction. Let's take a look at union first. When I click on union, my Boolean object becomes a union Boolean object. That is, these 2 objects, the cube and the sphere, become one object in a union. If I click on the intersect button, or intersection Boolean type, we get a new object. This object is a mathematical operation where the cube and the sphere intersect. We have the intersection object. So it only shows where these 2 objects share space. The subtraction object subtracts one object from the other. In this case, A, the sphere, minus B, the box. So we have a sphere with a box cut out of it. To reverse this relationship, click on subtraction B minus A. Now we have the box B minus the sphere A. So, Boolean operations come in flavors union, intersection, subtraction A minus B, and subtraction B minus A. You can change the way this is displayed by clicking on just the result, which shows you the result of the Boolean operation, or just the operands, so we see the 2 objects that we started with, or result plus a hidden operand, which gives us the result in shaded mode, and then the hidden operand in wireframe mode. Scroll back up with the hand tool, and we can delete this Boolean object by hitting the delete button. And now we can look at the next compound object type, the scatter. Before we do that, we have to go back to standard primitives. We're going to place a sphere in the center of our scene, and a cone off to the side. Doesn't matter where. OK. Go to the pull-down, select Compound Objects. Now, with the cone selected, click on Scatter Object Type. When I do this, you can see that I get settings for the scatter in the stack. The first thing I need to do is to pick a distribution object. To do this, click the button labeled Pick Distribution Object, and then click on the distribution object, in this case, the sphere. When I do this, you'll see that the cone attaches itself to the sphere. We can scroll down a little bit and see that we have our objects. Our source object is the cone, and our distribution object is the sphere. And under source object parameters, I can change the relationship by increasing the number of duplicates. And you can see that I'm scattering the cone around the surface of the sphere. And I'm increasing the number of duplicate objects by increasing the number right here in the source object parameters. I can change the scale to 100% or less to change the scale of those cones. And I can increase the chaos to deform the cone using chaos mathematics. And you can distribute the object differently by changing the distribution object parameters. Perpendicular, or use selected faces only. I'm just going to choose perpendicular and distribute using different methods. You can distribute using area, using even, using skip n faces, so skip every nth face, using random faces, along edges, along all vertices, all edge midpoints, and all face centers. And these just change the distribution of the cone along the sphere. And again, we can display just the result or the operands. Now we've just described two different types of compound objects: the Boolean object and the scatter object. There are four others, and I suggest you read your 3D Studio Max manual to describe and learn about these. The reason why I chose the scatter and the Boolean, because we only have enough time for two, and I decided that these two are the most useful of the compound objects.